Hello there. This is I'm tongue-tied. This is a video for the polar graphs that we explore, and there are just three basic forms that we look at. So I've got a pair for cosine sine where we've got a coefficient added and multiplied, and then that's just got a plain theta. And then we've got another pair where we've got the coefficient multiplied in front of the trig function and a coefficient for the theta. And then we have the third one. Now, this is really r squared equals b squared cosine 2 theta. Desmos doesn't let me do r squared, so I had to do the square root. So one of them is just plain theta. One of them, the multiplier or coefficient of theta will change. And then one of them is always 2 theta, and it's the one that's squared. And so this video, I just want to talk about some of the similarities between the three. And those are going to be the primary axis, the axis of symmetry in some ways. Cosine is x. So for all semester long, we've associated cosine and x, sine and y. And we want to keep that association. So you can see any of the forms that we do. Now this one, flower petal, the default is the x. So if any part of the graph is symmetric about x, then that's going to be cosine that you use. And we'll talk about what the letters B and C do in more detail a little bit later. But I just wanted to start off with that one common thing for all of them. And you can see this one with the 2 theta only ever has the 2. It looks like infinity, like that. So the sine, the default is not x. So now for this particular one where we have the a plus b, it's pretty obvious that this is just y there. The b times the flower petal, you see this one isn't on any axis. So the idea is that if it is x, no matter what, it's always cosine, and then anything other than that is sine. So depending on the numbers that are involved, you can see this one is sine. It doesn't have any symmetry doesn't have a petal on any axis. It's symmetric, left, right, top, and bottom, just like the other one, but it's not on the axis itself, whereas this one is on the axis itself. And let me change the C so we can see that a little bit different. So you can see this one has an odd number of petals, and the petal is on the x-axis, versus the sine, it's on the y-axis, but it's not on the x-axis. And then these guys, like I said, it's either horizontal infinity or diagonal infinity, quadrant 1 and 3. We don't do anything else. All right, so I'm going to start with this easy one and do just a little bit short exploration, and then I'll have separate videos for the other two to talk about how the numbers work on things. So this one, you can see from the origin to the outer intercept on the graph is that b value, 4. So now you might see this equation written out, r squared equals 16 cosine 2 theta, and then draw the graph. So you have to know both, graph to equation, equation to graph, but it's kind of easier to visualize like that. And this is, again, always 2 theta. So let's see if we make that b negative. Of course, it will be squared. It won't make any difference, will it? And then sine, diagonal, and if we make that negative, a different number. So I didn't change this to my polar so we could see it. This will be on the polar grid. So you can see from the origin to the outer edge is on that circle radius of 5 right there. And similarly for the cosine, but the negative doesn't change anything. And I think I'm going to stop there to keep these short. So remember the similarities. If it's anything on x, then it's automatically cosine no matter what else there might be. If it's not on an axis, So again, if this were a 4 there, so we've got the green dotted line. Clean those up. It's not on X, it is on Y, therefore it's sine. Alrighty, let's stop this and see how 5 minutes.